Hello everybody. So in the previous videos, we've talked about all the different protocols like TCP or IP that do very specific things in the entire system that works together to form the internet and make the internet function. So today we're going to take a look at how all of those protocols work together and how what the process is when you're trying to, say, download data from a web page in the internet or transporting data from one host to another. So how it works is basically through the Internet Protocol Suite, which is the collection or framework of protocols that is used in the internet. And when communicating over the internet, we can break down the process into different layers. So firstly, at the very bottom, there's the physical layer, which is how the bits are actually, so the zeros and ones, are actually transported from one place to another, like physically. Think the most physical level, which is like, fiber optic cable or a copper cable or through wireless or whatever. So this is responsible for the actual transport. Now exactly how the bits are encoded in the physical layer, that is the job of the layers that are above it. And next in the line, we have the data link layer. So basically what this layer is responsible for is transporting data from one node to another in a network. It could be like a local area network or a LAN or something else. But yeah, it's mainly responsible for transporting data across a single network. And so next we have the network layer right above the data link layer, which is responsible for both routing and addressing from one host to another. And by host, we want to remember that means like it could be like a different computing device that is capable of receiving data on the internet, or like a server, basically any computing device that's capable of receiving data from the internet. Now, if you think that sounds familiar, you're right, because it is what we talked about before, called the Internet Protocol, or IP. So that is one of the protocols that's working together with a bunch of other protocols, and it's one of the most common protocols used today to both route and address. And if we remember, routing is basically finding a reasonable path of routers, like transporting from one router to another, essentially finding a route for whatever data packets that you happen to be sending. And also IP also provides a form of addressing, which is uniquely identifying each individual device that is capable of connecting to the internet. And next up in the layer is the transport layer, which is responsible for the actually transporting the data, not physically transporting the data. That's like the physical layer, right? So through like copper cable or through optic cable. But the transport layer is basically, preparing the data in a way that is easier to be transported and received. And again, that does sound familiar. So we remember that protocols like TCP and UDP, the transmission control protocol and the user datagram protocol, that's responsible for encoding the data that you send into packets and providing headers like, for example, destination headers for other protocols like IP to successfully find a route from one network to another. And lastly, there's the application layer, which is the layer that users actually see, which is responsible for producing the data that is to be transported across the internet. Either that or something else on the user end, for example, preparing the data that is received from the internet. So one notorious example of that could be HTTP, which we recall is the protocol that is used to essentially download data or download the HTML data from another computing device or a server. And this is a simplified version of the process. In reality, there are a lot of other layers that are responsible for this entire process, but this, in my opinion, is the key layers that make the magic happen. All in all, a brief summary of everything that so far we've talked about. The internet, I've noticed in my process of learning about it, is actually very, very cleverly designed. It's not a system that you have to connect to or is a piece of software that is being maintained by a group of people. It's nothing more than a series of protocols that describe how the internet works, and that those protocols that all work together and also kind of adapt. It's almost like a living organism. What do I mean by that? Well, there are some characteristics of the internet that are almost like magic. So for example, if a new router suddenly connects to the internet, there's no conflict or anything. It's not like the IP protocol has to invent new routes that involve the new router. The router, it's dynamically routed, which means that if there's a new router, it fits into the process of routing automatically. There's no need to update a database of paths that can be taken by transmissions. So, and also if a section of the internet is down, and I know that sounds a bit abstract, but a section of the internet, as in like, say, a bunch of routers that all belong to a company, there's no worries, because the rest of the routers can automatically switch routes. Usually the internet, well, right now, as of today, the internet is designed in a way that it doesn't rely on certain articulation points that, you know, if are cut off, then the entire internet collapses. So the entire internet doesn't rely on like certain routers to be connected. It can always reroute. So as a result, if an entire section of the internet is down, aka a bunch of routers, or I don't know, like a service like Google, the entire internet won't just collapse. In fact, it's very difficult for the entire internet to collapse all at once. And another interesting thing about the internet is its scalability. So as of right now, no matter how many new users are introduced to the internet, it'll work fine. Like, since the advent of IPv6, it can allow for trillions and trillions of new users, whereas with IPv4, there was like a very limited, it was like 4 billion something, and we've already exceeded that limit of users that are using the internet now. But with IPv6, and also with, you know, how the internet is designed, no matter how many users there are, the internet will continue to function. And yes, it's not just an unstoppable being. There are limiting factors that limit how much it can be scaled by. For example, there's the factor of bandwidth. You know, bandwidth can never be infinite. You can't transmit data instantly. There's a certain factor that limits the speed when transporting data from one place in the internet to another. And for example, there's limitations like how many connections a single router can sustain. You know, if there are too many connections trying to be sustained by the router can't take that many transmissions. I think it's usually like 250, and maybe it'll just cause like a traffic jam, metaphorically. So that brings an end to this video. In this video, I know we kind of talked about two different topics. So first, we looked into how the different protocols all work together, and we also looked at the scalability of the internet and how the internet, basically how cleverly designed it actually is. Goodbye.